Hey, in today's interview, I'll be talking to Evan Schnidman, PhD. He's currently the founder of EAS Innovation. But I know him back from his time when he was founder and CEO of a company called Prattle, which was a natural language processing company for the financial world of financial news and documents, which later got acquired by LiquidNet, where he continued to work with it as head of data science. Evan is a fascinating individual and incredibly intelligent, which is why I'm so excited to be talking to him in our ongoing series, connecting the world of data science and the world of business. Take a listen. Welcome, Evan. How are you, my friend?
I'm great, Dan. How are you?
I'm doing very good. Hunkered down in San Diego, which is far better than me being hunkered down in my other location of choice, which is New York City.
I can relate to that. I am very happy. I live on a bunch of land in Connecticut and not in a small apartment in New York these days.
Exactly. So you and I have known each other for quite some time. You're an advisor for Gravity AI. We met, if you recall, at a conference where I was a panelist, and I believe you spoke at the same conference out in New York City. And just had a lot in common, and certainly we're both working on AI technologies. So why don't you tell us just a little bit about yourself?
Yeah, absolutely. I will say I vividly remember meeting you at that conference because I was so impressed that someone who was employed by State Street was dressed so casually while presenting at a conference. So no, it was what drew me to go have a conversation with you. So
full disclosure, I bet you don't even know this. I was extremely hungover that day as well. I had been traveling like crazy, and I was on a super long flight the night before. And I magically had business class. I got that free upgrade, and they like to fill up your wine glass in business class.
They do. I have experienced that and gotten off a plane on more than one occasion and said, I'm gonna take a breather here before I have to get in the car and drive home. So
this feels a little tipsy here. Yeah.
Yep.
Well, thank you for that. So I think the big thing, and you were working at as CEO of Prattle when we met. So tell us a little bit about that. Tell us a little bit more about your background.
Absolutely, yeah. So I actually started my career as an academic. Was basically I often joke I'm a recovering academic. You never recover; you're always recovering from academia. So I started my career as a game theorist, actually, and so I was modeling small group decision dynamics. And during the financial crisis, the most interesting small group of decision makers I could think of was the Federal Reserve. So I set out to model how the Fed makes decisions and how those decisions affect financial markets. In that process, I realized that the markets don't actually respond to the decision dynamics or even really the policy. It's all about communication. How does the Fed communicate? And so as I delved into that, I realized very quickly that the state of the art in analyzing so-called Fed speak was basically subjective. It was, they seem more hawkish or feel more dovish. And no one had imposed any scientific rigor on that. And so I set out to impose that scientific rigor. And the best tool I had in my arsenal was natural language processing. So I delved into sentiment analysis and looked at the computational linguistics literature pretty closely and realized, hey, the existing practices aren't going to quite cut it for something that's language that's this complex, this nuanced, and this veiled. And so as I looked around the literature and used a little bit of the math background I had, I was able to work through the math and say, I think that there's a way to mathematically map linguistic patterns and tie them directly to price action. And so as I started to build that out, I started thinking, this might be a business here. And I finished my PhD at Harvard. I'd been faculty at Brown for a little while, and started talking with actually a guy I'd met at a conference. Apparently these guys I meet at conferences are actually important. So, we started chatting, and he had much better background on the pure dev side than me. And so Bill McMillan, my business partner, became my business partner, and we really built out a system that underpinned what eventually became Prattle. And so we built out an analysis of every major central bank in the world, analyzing all of their publicly available primary source communications and providing sentiment scoring as tied directly to price action.
Mm-hmm.
And so we could say that it's not an abstract term, this is hawkish or dovish. We can say that the market is likely to respond as though this is hawkish or dovish.
Super
That
cool.
propelled us to creating a macro research brand, and ultimately to listening to our clients and finding out that turns out that people are not only struggling to analyze central bank communications, they're drowning in corporate communications. And that
Oh
was
yeah.
the consistent feedback from portfolio managers. And so we raised some venture capital money and built out a system that ultimately analyzed about 5 million documents a day. Every primary source communication from every publicly traded company in the United States, as well as a variety of other publicly available sources. And obviously there's a whole data science back end that we built. Turns out that a lot of the tools that are available here in 2020 weren't available in 2015, 16, 17. So we built our own back-end data science infrastructure, scaled that up, and so it was a wild ride. We sold Prattle in early 2019, and I spent a year at LiquidNet, really integrating that system and building out an investment analytics framework.
So cool. I think it's so funny too that you point out the technologies in just the short span of those 3 years, like didn't exist, and you guys had to build it yourselves. One of the things that has enabled Gravity AI to even exist is the fact that now these things can go and get bought. The speed at which it's moving is crazy. But when I was at State Street, I was obviously, one of the other reasons that we spoke so much is I was evaluating Prattle as a tool for us to use that we might buy. And I just thought it was super cool what you guys were doing. Such a powerful use of data science on just a huge amount of information.
Yep. No, that's exactly right. And it's amazing how far the technology has come. Not in that it's more sophisticated than it was a couple of years ago. It is a little bit, but not a lot. Where what it is, it's so much more readily available. And if we had tools like the current iteration of Airflow and Snowflake, we wouldn't have had to build our own backend data science infrastructure. We wouldn't have had to build a system that went from static models to fully deployed production level code through a series of drop-down menus, because that functionality now exists in other places. But when we did this in 2017, it didn't. None of those things existed.
It's incredible. So with that, and obviously Prattle was your own company, and having known you for a little while, I get the sense that you and I both share a disdain for authority a little bit. It's gotten me into trouble on numerous occasions.
Yeah, it's gotten me in a little bit of trouble too. Yeah.
So, I'm going to ask you the same question that I ask everyone, which is, what is one thing that you wish that business executives, knew about data science?
Yeah, and honestly, first and foremost, the big thing I wish that executives understood is that data science is in fact a science, right? That being able to go through the scientific method and actually empirically demonstrate that you are proving out a hypothesis, right? That it means you're going to get null results sometimes. If you're not getting null results sometimes, then you aren't designing real experiments. You aren't actually exploring the data that's available to you. If you're only going out there to confirm your previously held beliefs when you're certain the data is going to be in your favor, then what's the point in doing the data science work at all, other than to say, look, I was right? Well, that's all well and good. What the point here is actually that organic discovery of new scientific facts, new findings.
So let's dive into that just a little bit and unpack that, because describe what you mean to me as a null result, and because I think that a business executive might see that as a failure, right?
Yeah, and that's so a null result functionally means that there's no conclusive finding, that the data doesn't indicate one direction or the other, that this is either true or it's false. It just says, this is inconclusive. We may not necessarily know. In all likelihood, you may be able to add supplementary data and actually have a conclusive finding, or it may be that there is no statistical relevance to whatever you're studying. right? Sometimes things are just a coin flip or pretty damn close to it. And
Yeah.
sometimes there really is a rigorous finding that is actually statistically significant. But more often than people like to admit, the results can be kind of ambiguous, and that's okay. That means you're designing real experiments and exploring things where there isn't certainty in what the outcome's going to be.
Yeah, the goal is to find the truth, not to confirm that this model does X, Y, and Z, because that doesn't serve anyone well if it doesn't actually do that.
Well, and in fact, I would actually argue it's not just to discover the truth. In some cases, the best thing that data science can do for you as an executive, as a decision maker, is help mitigate your cognitive bias, help you stop yourself from making bad decisions, right?
I love that.
Helping you make good decisions is important, but stopping you from making bad decisions might be more important, especially in the world of investing, right? How do you make money over time? You don't lose it when the market goes down. If you don't catch as much on the upswing, you're still better off than if you're level in the downswing because you didn't lose it, right? If you never lose that principle, you're just better off. The same is true in business. If you don't make disastrously bad decisions and you make incrementally good ones, you're going to be a lot better off than if you're wildly swinging between bad and good decisions.
Yeah, I love that. So I guess, if I were to ask you, what would you tell an executive who looks at a null result as a failure? That sounds like that would be the answer to that, right?
Yeah, that's exactly right. And it's, one of the things that as I said before, I was trained as a game theorist. So I think a lot about decision dynamics, right? How do you optimize your own decision dynamics, whether as a manager, as a portfolio manager, as a people manager, regardless of what your role is, right? You have to be able to make consistently good decisions. And the challenge that people face is they get in their own way, right? Human beings are pretty terrible at identifying our own biases, myself included, especially economists. It's a real problem. But no,
a recovering academic and a recovering economist.
Yeah, that whole world is, it's challenging. You have your beliefs, and I think we all do. And we come into situations with priors, and if the data can force us to reevaluate those prior beliefs, then we can actually make a better informed decision, right? It's just increasing the number of veto points in your own mental decision process. And that's really what the tool of data science is in most corporate settings. It's helping you improve decision making.
This kind of gets into another thing that I've heard from business folks in the industry, which is the quote, "This can't be another science project." But science is directly in its name. It is a science, as you said. How have you kind of dealt with that with business folks, or what would you tell them around that?
Yeah, it's funny. I look at the "it can't be another science project" quotes as it reminds me a lot of the fact that years ago my degree was actually in political economy, so I spent a lot of time split between the economics department and the political science department. And political scientists are very touchy about the fact that their discipline is the only one that has to be called science, right? And you don't call it biological sciences or chemical sciences. You call it biology, chemistry. Economics isn't economic sciences, right? So political science had to justify its existence as scientific for decades before data science is now facing the same problem. And what's amazing to me about this is good political science and good data science have so much in common. It is scientific. It has to be. You have to actually lay out that hypothesis and test it. If you don't, going back to what we were saying before, if you don't get null findings once in a while, you're not designing experiments right?
Right.
If you're only exploring the things where you know the answer already, then that's essentially just marketing research. That isn't even data science work.
Right.
You're just going out there figuring out what to message. You're not even figuring out what to say. And so really the biggest sort of challenge in that sort of that science project mentality is I think that people don't want to see money wasted. And I think that's an honest concern. It's an earnest concern, and it's an important one. And data scientists are expensive. Data science projects are not cheap necessarily. And so the big challenge is how do you prove your value? And it's around improving those decision dynamics, right? So if you can actually yield data, right? Yield insights that helps the core business operate better, or at the very least, not make bad decisions, then you prove your worth.
That's fantastic. I love that framing, and I think that's the right way to talk about it. And I love the idea of data science having to justify itself as a science. It's crazy to think about that. You, just like as you mentioned with political science, that it's just not thought of like that. And if you can convince someone that it's worth it to spend the money on discovery, you're going to get so much more out of it. And I think this is actually one of the bigger problems that underpins business in general, is the idea that we don't want to spend money to not get a result. We really need an innovation in funding approaches when it comes to these types of projects, and in a different way of thinking about that at the end of the day. I think that's the only way that we're going to start seeing more successful data science projects that lead to things in production that are being actually used.
I think that's exactly right. And I think one of the tricky parts about that is people often conflate the roles of the data scientist, the data engineer, the analyst, et cetera, right? And one of the challenges there, as people conflate those roles, that you're now in this crazy version of the world where people will spend a great deal of money to hire a qualified data scientist and then say, don't do science, right?
Right.
And well, if you don't want them to actually engage in scientific discovery, experimentation, and actual projects where they're looking to yield insights, then you hired the wrong person. You hired the wrong role, right? If you just want to build out data infrastructure so that the data is more accessible for a business analyst to pull data for some known purpose, that's a data engineering role. That's an important role. It's a vital role, and it's the vast majority of what data work is. But the reality of it is that's not the role of the data scientist.
So let's get into that. So I'd love to hear, because I don't think this is well understood in the business community, what the difference between a data scientist is versus a data engineer versus a data analyst, maybe even formally like a business intelligence type person. I have heard from some very senior data scientists, they believe that they should continue to operate in all three of those functions. I'm more of the mindset that it does start to make sense to divide that into three separate roles, or even, now you're even starting to see ML engineers that is different than a data scientist. Can you break down for us what you think the big differences are between those?
Absolutely, yeah. And I think, I absolutely see where, some of the people you're talking to are coming from on that, which is I genuinely believe that a data scientist, especially a data science manager, should sit at the apex of an organization that has data engineers, analysts, maybe even database administrators in there as well, right? Yeah. They all they have different functions, but the data scientist should not be the one doing data QA work or managing the load on your SQL server, right? That is not a good use of their time, energy, and skill set, right? They should be doing the more creative discovery work, right? They should be actually designing an experiment. They should be analyzing the data, right? So the fundamental difference here is if you're going to do basic data analysis, basic just descriptive statistics visualization, that's a business analyst or a data analyst role, right? If you're going to do data infrastructure, the plumbing, right? That's a data engineering role. Now, if you want to have sort of the organizational maintenance and the structure there, you can actually have a database administrator. Now, what ties all those things together is that you're using the data for some purpose. Where it's gotten much more interesting in recent years is people have realized it's not just, hey, let's confirm our previously held belief by having a data analyst pull some data and throw it into a basic graph, right? It's let's actually analyze this. Let's combine data sets. Let's procure different data and add it in and run a multi-factor model, right? That's where the data scientist comes in. Now, when you start adding in ML engineers and really breaking into the AI space, in some sense, those are distinct roles, right? I know great data scientists who, frankly, are just better ML engineers than they are data scientists, right? Yep. If you're starting to do if for instance, you're trying to build out a named entity recognition framework and you wanted to start building that out from scratch, you probably need to be running some neural nets models in order to identify that Tim Cook from Apple is not somebody named Tim writing an article about cooking apples, right? Like those are different things. That is actually a machine learning process that they're running, right? And so that's, you know, if you're going to do that, you're going to end up running a bidirectional long short-term memory model, for instance. That's pretty sophisticated stuff. That's decidedly in the machine learning space. Not all data scientists are going to be experts at that, nor should they be. So that's where you start getting into specialized ML engineers as well.
Yep. Yeah, and I think it's such an important point for business folks to understand the difference between these. One, so that they can understand, you know, where they are in kind of like the AI adoption curve, right? If they don't have the data infrastructure to support data science, you should probably start looking for hiring a data engineer, right? And that distinction between those roles becomes very important for that reason. The other reason it becomes super important is there's a distinct difference in cost between these types of resources. Data scientists charge one rate that is different, typically more than a data engineer, who charges one rate that's typically more than a data analyst, right?
Absolutely. And by the way, there are also variations within data engineering, right? People who've only ever done manual QA are very different than people who've done scripted QA or people who've actually built data systems, right? If you've actually built out a data warehouse and have actually organized something yourself, that's a very different kind of data engineer that probably has done some DBA work as well, right? But they're also that's still distinct from data science and the exploratory or experimental work that a data scientist does. But you know, the fresh college grad who knows a little bit of Python and can maybe script a few things, but mostly does manual QA, they may call themselves a data engineer, and they're not wrong to do so, but that's a very different skill set than someone who's 10 years into their career and doing scripted data engineering. They've automated away a lot of the QA tasks. They've built out data warehouses. That's still a data engineering role, but it's a more senior one. And there's nothing wrong with being a senior data engineer. Many of them do want to jump to being data scientists, but that's a different skill set. It's in some sense a creative skill set of being able to come up with experimental design and actually understand how to implement that. Whereas it's much less of an engineering skill set of understanding how to manage the system.
Yeah, really good distinction. That's probably my favorite distinction that I've heard someone describe between those different roles. That was fantastic. We've picked on the business executive a little bit right now for not fully understanding the data science world. And, you know, really, it's not entirely their fault. You know, it's still, as we were talking about earlier, the technologies have changed so drastically, even just in the last 3 years. And in its relative maturity, it's still fairly young. So let's kind of turn the tables a little bit. You know, I asked you, what do you think executives or data scientists wish executives knew about data science? Let's turn that around. What do you think executives wish data scientists knew about the business side?
Everything. I just had a call earlier today with one of my consulting clients about this, and this exact question came up, which is, you know, okay, we're expanding our data engineering function. We want to hire a data scientist. You know, should we just upskill one of our business analysts so that we have somebody who understands the actual core business? And basically my immediate reaction was, it's going to take far too long to take your average business analyst and get them upskilled to being a data scientist. You're much better off getting a skilled data scientist and training them on the business. Now, that said, it's a valid concern. I mean, I think that the vast majority of executives look at people who are running these dense empirical tests and say, why would you ever test that? We obviously know the answer, right? Yeah. And so there's a lot of wasted energy with people who may or may not have any understanding or grounding in the industry they're operating, testing things that have obvious answers. And my favorite example of this is I was at I was at a conference once, and I was sitting there waiting to present, and one of the presentations before me was another startup. This is when I was running Prattle, and what was remarkable was that the CEO of this other company was very proudly proclaiming that they're able to predict the volatility of the Federal Reserve based on their data science models, right? Essentially, the volatility induced into the Treasury markets by the Fed,
Yeah.
with a high degree of predictability several days in advance. And I couldn't help myself. I pulled up my phone and took one look and Googled FOMC calendar, and I looked at the graph that was on the screen and looked at the calendar and said, "Oh, okay. So I could predict that a year and a half in advance, not just a few days, because what you just did was identify when there are Federal Reserve Board meetings. They hadn't
Known signal that everyone has on their calendars already.
Right. This is a calendar that's released over a year ahead of time.
Yeah.
It's but because they're not domain experts, they did this as a pure data discovery exercise and said, "Oh my gosh, we can predict volatility." Well, yes, but anybody who paid attention to a calendar could have predicted that volatility a year earlier than your data science model. So you have to have some level of domain expertise married with the actual analysis. So pulling someone in who's the greatest statistician in the world but knows nothing about your business is going to make it really hard for them to yield valuable insights about your business.
Yeah. Do you think that's a function of a lot of data scientists coming from academia?
Yes. Yeah. And in fact, I actually would say one of the big challenges for data science as a discipline is that it actually has not been a standalone discipline for very long.
Right.
So data scientists can come from very different backgrounds in their training, right? So you can have computational neurobiologists, you can have economists, and you can have sociologists all calling themselves data scientists, right?
Yeah.
And not to mention the people who actually have a run-of-the-mill PhD in applied statistics, which is what we would have considered a data science role 5 years ago, right?
Yep.
And so the big challenge is because of that diversity of backgrounds, some of those people are going to have a good understanding of your core business if you're in one of their disciplines, right? If you're a computational neurobiologist and you're working for a healthcare company in that space, then okay, that's probably not so hard to lift, right? If you're an economist working for a financial services firm, you should have some basic understanding. But in many ways, the very best data scientists I know actually come from non-traditional backgrounds. So many of them come from the social sciences where there's measurement error, right? Sociology, psychology, political science, right? These are areas that are messy because they're human. And so what happens is you've got a lot of data that has significant measurement error. So they're used to dealing with messier data problems, bigger data problems, and they're not necessarily strict time series like we might see in economics, right? Or finance. And so a lot of the best data scientists really, they come from areas where they've had to develop a skill set that caused them to learn more about the problem before they try and answer it. And so I think that, as data science matures as a discipline, we'll have to inject more of that learning, more of that understanding of the broader problems that the business is facing, that the industry is facing. That'll have to be injected into that curriculum, because it can't just be that pure statistical work.
I love that. And that actually is going to bring me to my next question about this. So my question is, you've seen that famous Venn diagram that makes its rounds on LinkedIn and social media of what a data scientist is, where it's computer science in one circle, statistics in another circle, and business. And the intersection of that Venn diagram, is a data scientist. I feel like that business portion, kind of like we were just talking about, is very little understood from a data science perspective. So in addition to domain expertise, like what we were just talking about, what do you feel should be in that business category? And how do you feel about the state of data scientists with that business intersection today?
Yeah, so I think it's a fascinating question, because one of the sort of falsehoods of that diagram is to assume that all of those three circles are weighted equally, right? And in some sense, yes, the core skill set of the data scientist is mostly statistics, some computer science, but the business function is actually the one that has the greatest breadth, right? Now, the data scientist may not need as much depth of knowledge on that, but the business function can be so broad, and there's so many different aspects. To say you do business as a career would be a ridiculous statement, and everyone knows that. We intuitively know that. So to say that, like, oh, you know, the business analyst that's an intuitive role. It means different things in every organization. And so for a data scientist, the important part is to develop a specialization, to actually have some knowledge of what it is that organization does, right? If you're a great data scientist who's only ever worked in the healthcare space, it's going to be really hard to jump into finance, right? And vice versa. Now, that doesn't mean you can't develop that skill set. That doesn't mean you can't learn those business functions. But if you don't know the acronyms, if you don't know the core business model, you're going to be measuring things that are already settled fact, and you're going to be missing things that are actually highly disputed.
Yeah, I'm with you 100%. It really does come down to knowing what to test, what's appropriate to test. Along those lines, though, do you think that organizations put too much requirement on the data scientist in that business, category? I mean, I have an MBA and I paid a lot of money for that MBA. Questionable how much value I got from it. But you have an entire academic school, of thought that is dedicated to understanding what that broad category of business is. And here you have organizations putting a lot of this requirement, understanding business problems, as data scientists like to say, onto the data scientist. Is that fair to say? Do you think there's too much pressure being put on them to have to draw that kind of business problem out?
There's not. I actually think that the data scientist needs to catch up there. I do. And so one of the challenges in data science as a discipline is, it's not a purely academic discipline. And frankly, it probably never will be. And nor necessarily should it be. Data science exists to serve various different industries, right? And so it is a business-focused discipline. And that means that you have to understand the core business problems. Now, the flip side of that is there's only so much time in the day. There's only so many things you can master as one person. And so you need to build the right team around you. You need to make sure that you have the right tools. So one of the things that always drew me to the vision of what you're doing with Gravity is the fact that if you can make the data scientist's job easier by actually having a set toolkit in front of them, they don't need to go out and figure out what to use. They already have those tools, right? It's less headspace to define the entire menu of options, and more headspace devoted to solving the business problems.
Yeah, that's a really good point. I do think that, and I'm going to ask you momentarily about build versus buy decisions and how business, because oftentimes there's business folks involved that don't understand these implications, but also I think that data scientists don't understand. Their natural state is they're data scientists. They want to build it, right? Because they're probably brilliant and they can solve this problem. But really quickly on that last point, I think we're at a point in time where there are things finally that work really well off the shelf. And because of the ubiquitous nature of large, free, open, public data sets, and the fact that you've got all these kind of fragmented shops who are building things, data scientists, and I'm almost answering my own build versus buy question here, but data scientists need to be freed up to work on those really proprietary problems as opposed to things that have been solved. So how, when you, because I know that this is a question that probably came up in Prattle all the time, and, you guys built some very, very powerful NLP and sentiment. And while I was at State Street, State Street's trying to invent their own version of this, and which I always thought was silly. What would you tell both an executive and a data scientist about build versus buy decisions in the field?
Yeah, so that is the build versus buy question is so profound, and it's constantly changing, right? So 5, 6, 7 years ago, you didn't have off-the-shelf NLP tools that were worth anything. I mean, they were useless. Now, NLTK as a Python package gets you 80% of the way there, right?
Yeah.
And so, there's a lot of things like that that have really changed and evolved as the last couple of years. We've seen a lot of that stuff become available in the open source communities, available in, really, really readily accessible packages. And so a lot of the infrastructure stuff, a lot of the data engineering work, that stuff, you shouldn't be inventing the wheel. There's known best practice. There's existing tools. There are good things to pull off the shelf there. Now, when it comes to proprietary data science analysis, that's when you need to decide, do you need to develop the algo yourself? Can you cobble together something from existing algos? What's the best play, right? And to me, that's where I think a lot of business executives may not know, hey, there's this huge distinction between data science and data engineering. But two, there are things that are unique about your business. So yeah, you shouldn't reinvent the wheel, but if you're actually driving a tank and you need treads, that's a little bit different, right?
Yeah.
And so it's just a different endeavor.
And I think that's a very apt analogy. When you're thinking about as a data scientist, those proprietary problems versus things that might be off the shelf, oftentimes you don't necessarily have to have something proprietary that you've built from scratch. It's really about how you've put those pieces together for your industry. And then if you need one of those pieces, like tank treads, to be custom, that's what you spend the time on.
Right, and that's exactly it, right? So you can pull together off-the-shelf tools for the entire build, right? But your ability to connect those things, right? That may be what's proprietary. Or maybe the data you have is proprietary. Or maybe even just the question you're asking is the proprietary part of it, right? Maybe you do have to do the last mile, build out yourself, and actually do some scripting and actually create something truly novel. But there are not that many problems where that's the case. So great data scientists are actually going to know what are the coding libraries, what are the available tools that they can use. They don't have to reinvent the wheel. That's
perfect. Yeah, that's great. Evan, this has been an absolutely fantastic conversation. I think we're going to actually have to do, I'm going to get you to commit to it, a part 2 of this, and where we dive into some other aspects of this world, because there's just so much to discuss here and unpack. And I think you've got just a really insightful way of communicating about it and talking about it. So thank you a ton for coming on.
Thank you for having me. I'm so happy to come back and do this again anytime.
Yes, I'm holding you to that. Any last words for aspiring data scientists or executives looking to use the next big thing in AI out there?
I think the last big words are, remember that all problems are not necessarily solvable, right? You can't necessarily find the ground truth behind something if the data doesn't tell you it, right? And so all of this boils down to making sure you have the best data and making sure that you're not wasting your time as a data scientist, as an executive. You're not wasting your time building things that no one's ever going to use, right? If there's tools out there that already exist to solve the problem, use the tools that solve the problem and focus on making sure you have the right data and you're asking the right questions.
Fantastic. Well, thank you, sir. It's been a pleasure. Have a good one.
Thanks, Dan.
Bye.